Welcome to all of you. Today we will start our mathematics paper 2nd from the topic differentiation. So let us revise basics of differentiation which you have studied in the last standard. Firstly we will see the definition of derivative. If y equal to f of x be a function of x and suppose h with a small increment in x, then derivative of f of x with respect to x at any point is defined as f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. This is the first principle of derivative. Suppose we have to find derivative of y with respect to x at particular point x equal to a, then we have to replace this x, every x by a. Therefore we can write here f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h. This is the first principle of derivative. In the last standard you have studied this first principle, and using this theorem or this first principle you have solved some examples. Now let us see some remarks. First remark is if the derivative of f of x exists, then function is said to be derivable or differentiable function. Second remark is the process of finding the derivative is called as differentiation. The third remark is important remark here. Leibniz notation of derivative. If y equal to f of x is a differentiable function of x, means derivative of y with respect to x exists, that is dy by dx exists. It is denoted by dy by dx, derivative of y with respect to x. If delta x is the small increment in x and the corresponding delta y in y, then limit delta x tends to 0 delta y divided by delta x is equal to dy by dx. So the meaning of y is differentiable function of x means derivative of y with respect to x exists and is given by limit delta x tends to 0 delta y divided by delta x. Similarly, if suppose u is a differentiable function of x, that means derivative of u with respect to x exists and it is given by limit delta x tends to 0 delta u divided by delta x. Similarly, if v is a differentiable function of x, then dv by dx exists and it is given by limit delta x tends to 0 delta v divided by delta x. Suppose x is a differentiable function of t, then we have to write here dx by dt, derivative of x with respect to t exists, dx by dt is equal to limit delta x tends to 0 delta x divided by delta t. So this is the Leibniz notation of derivative. This can be used to prove theorems in this chapter. Now we will recall some rules of differentiation. The first rule for addition and subtraction: if u and v are differentiable functions of x, just we have seen u and v are differentiable function of, the meaning of differentiable function of x means, suppose y is expressed as addition and subtraction of addition or subtraction of two functions which are functions of x, then dy by dx equal to du by dx plus or minus dv by dx. फंक्शन जर ॲडिशनच्या फॉर्ममध्ये एक्सप्रेस केलेला असेल तर इकडे डेरिव्हेटिव्हची ॲडिशन होईल. सिमिलरली सबट्रॅक्शन असेल तर सबट्रॅक्शन ऑफ डेरिव्हेटिव्स. The second rule is important here. If y is expressed as product of two functions, here u and v are also differentiable functions of x, then dy by dx equal to u into dv by dx plus v into du by dx. u आणि v च्या ऐवजी आपण फर्स्ट आणि सेकंड असं सिंपली लक्षात ठेवू शकतो. dy by dx equal to first as it is derivative of second plus second as it is derivative of first. The third rule is if y is expressed as quotient of division of two functions and the condition as denominator must be not equal to 0, then dy by dx equal to v into du by dx minus u into dv by dx divided by v square. In the first and second form, this rule can be determined as second as it is into derivative of first minus first as it is derivative of second divided by square of second. So these are the rules of differentiation. Now we will see derivatives of some standard functions. इथे दोन कॉलम्स आहेत, y इक्वल टू f of x आणि दुसरा कॉलम असेल dy by dx equal to f dash of x. The first function is constant function. Consider any constant as a constant function. We know that derivative of constant function is 0. Derivative of x raised to n, that is power function, is n into x raised to n minus 1. पॉवर फंक्शनचे यूज करून इथे आपण 3 फॉर्म्युले डिराइव केलेले आहेत. If n is equal to 1, then x raised to 1, that is only x. Derivative of x with itself is 1. Derivative of root x, consider this root x as x raised to half, and using power function we will derive this formula 1 upon 2 root x. Derivative of 1 upon x is minus 1 upon x square. Now the next functions are trigonometric functions. Formula number 6 up to 11 are trigonometric functions. Derivative of sine function is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. Derivative of sec x is sec x into tan x. Derivative of cosec x is minus cosec x into cot x. निगेटिव्हचा क्रायटेरिया लक्षात ठेवण्यासाठी इकडे ट्रिगोनोमेट्रिक फंक्शन्स मध्ये ज्या ट्रिगोनोमेट्रिक फंक्शन मध्ये c येतो त्याचे डेरिव्हेटिव्ह निगेटिव्ह येतात. एवढी ट्रिक सफिशियंट आहे. cos x, cot x आणि cosec x या अल्टरनेटिव्ह फंक्शनचा डेरिव्हेटिव्ह निगेटिव्ह असतो. पुढचे फंक्शन्स आहेत एक्सपोनेन्शियल फंक्शन्स. e raised to x and a raised to x. These functions are known as exponential functions. हा सगळ्यात सोपा फॉर्म्युला आहे डेरिव्हेटिव्ह मध्ये. डेरिव्हेटिव्ह ऑफ e raised to x is e raised to x and derivative of a raised to x is a raised to x into log a. आणि शेवटचे दोन फॉर्म्युले आपण बघूया. Derivative of logarithmic functions. Derivative of log x is 1 upon x and derivative of log x to the base a is 1 upon x into log a. So these are the formulas of derivatives of some standard functions. By using rules of differentiation and these derivatives of standard functions, let us see some examples. First question is differentiate with respect to x the following. Addition and subtraction rule combinedly use करायचा आहे इथं. If y is expressed as here subtraction and here is addition, y is equal to 2 sin x minus 4 cos x plus 8x square. Given y is equal to, differentiating with respect to x, we get right here derivative of y dy by dx is equal to 2 as it is. हा सिंगल 2 असेल तर तो कॉन्स्टंट येणार आहे. हा ट्रिगोनोमेट्रिक फंक्शनला मल्टिप्लाइड बाय कोएफिशियंट आहे, तो कॅरी करायचा आहे. 2 as it is. डेरिव्हेटिव्ह ऑफ sin x d by dx of sin x minus as it is 4 as it is d by dx of cos x plus 8 as it is d by dx of x square, which is equal to 2 as it is. Derivative of sin x is cos x minus 4 into derivative of cos x is minus sin x plus 8 into derivative of x square is 2x. Therefore, dy by dx is equal to, finally, we can write 2 cos x plus minus into minus here is plus 4 sin x plus 8 into 2x is 16x. So this is the final answer. Now consider second example where y is expressed as product of two functions. या टाइपचे एक्झाम्पल्स 11वीच्या टेक्स्टबुक मध्ये आहेत. 11th स्टँडर्डच्या पार्ट सेकंडच्या तुम्ही प्रॅक्टिस करा. डिफरन्शिएटिंग विथ रिस्पेक्ट टू एक्स वी गेट dy by dx. फर्स्ट आणि सेकंडच्या फॉर्म मध्ये आपण आता इथे लिहिणार आहोत. फर्स्ट ॲज इट इज, हा एक्स येतो फर्स्ट आणि लॉग एक्स इज अ सेकंड फंक्शन. फर्स्ट ॲज इट इज दॅट मीन्स एक्स आहे असा इंटू डी बाय dx ऑफ लॉग एक्स plus second as it is, that is log x as it is into d by dx of x, which is equal to x as it is derivative of log x 1 by x plus log x into d by dx of dx by dx is derivative of x with respect to x is 1, and by simplifying, cancelling this x here, we will get 1. Log x into 1 is log x. Therefore, the final answer is log x is equal to 1 plus log x. So this is the differentiation by using product rule. Now we will see another example by using division rule. Division rule is d by dx of u by v equal to v into du by dx minus u into dv by dx divided by v square. y is expressed as x raised to 5 minus cos x divided by sin x. या पर्टिक्युलर एक्झाम्पलमध्ये जो न्यूमरेटर आहे दॅट इज यू फंक्शन आहे. हे यू फंक्शन परत दोन फंक्शनच्या सबट्रॅक्शनमध्ये एक्सप्रेस केलेलं आहे. सो लेट अस सी द सोल्युशन. डिफरन्शिएटिंग विथ रिस्पेक्ट टू एक्स वी गेट यू इक्वल टू एक्स रेज टू 5 मायनस कॉस एक्स आहे. टोटल लक्षात असू द्या. इक्वल टू v as it is that is sin x into d by dx of x raised to 5 minus cos x आहे असं मायनस u आहे असा म्हणजे x raised to 5 minus cos x into d by dx of sin x. आता डिवायडेड बाय काय येणार आहे v स्क्वेअर म्हणजे sin x स्क्वेअर इज इक्वल टू sin x आहे असं x raised to 5 या फंक्शनचं डेरिव्हेटिव्ह द्या 5 into x raised to 4 by using फॉर्म्युला फॉर डेरिव्हेटिव्ह ऑफ पॉवर फंक्शन मायनस आहे असं कॉस एक्स या फंक्शनचं डेरिव्हेटिव्ह मायनस साइन एक्स मायनस कॅरी करा एक्स रेज टू 5 मायनस कॉस एक्स इंटू डेरिव्हेटिव्ह ऑफ साइन एक्स इज कॉस एक्स डिवायडेड बाय साइन एक्स स्क्वेअर कॅन बी रिटन एज साइन स्क्वेअर एक्स. नाव सिम्प्लिफिकेशन साइन एक्स इंटू ब्रॅकेट 5x रेज टू 4 ॲज इट इज मायनस इंटू मायनस प्लस मायनस हा कॉस एक्स पहिल्यांदा आले कॉस एक्स इंटू एक्स रेज टू 5 मायनस कॉस एक्स डिवायडेड बाय साइन स्क्वेअर एक्स. Simplifying, multiplying by sin x into 5x raised to 4 plus sin x into sin x is sin square x minus x raised to 5 into cos x and minus into minus plus cos square x. We know that by fundamental identity sin square x plus cos square x is equal to 1. Therefore, the final answer is 5 into x raised to 4 into sin x minus x raised to 5 into cos x plus 1 divided by sin square x. So, this is the total revision of 11th standard. For more practice, you can solve the exercise from the topic differentiation of class 11. Now, we will start our actual syllabus of 12th standard from derivatives of composite functions. Derivatives of composite functions. Composite function means function of another function. If suppose this sine function here f of x is equal to suppose sin x and this x is replaced by another function, then it becomes a function of function, then it is a composite function. Sine of log x is a composite function. Sec of tan x is also a composite function. Similarly, log of 2x plus 3 is a composite function. Log of 2 raised to x 1 upon 2x plus 3, these are the examples of composite functions. Now we will see the theorem on derivatives of composite functions. If statement of the theorem is if y equal to f of u is a differentiable function of u and u equal to g of x is a differentiable function of x, then y equal to f of g of x is a differentiable function of x and dy by dx is equal to dy upon du into du upon dx. Proof of this theorem is, firstly we have to assume that we have to consider that this u function is not a constant function. Now let us consider increments. Consider delta x with a small increment in x. Now delta u and delta y with the corresponding increments in u and y respectively. Firstly, we have to consider the small increment in x. Y, see here, y equal to f of u and u equal to g of x. If we change this x or if we add small change in x, it affects on the value of u. And if we add small change in u, this will affect on value of y. Therefore, we have to consider firstly the small increment delta x in the x. So, let delta x be the small increment in x. Let delta u and delta y be the small increments in u and y respectively. As आत्ता सांगितल्याप्रमाणे as delta x tends to 0, small change in x must be, small change in x tends to 0, then small change in u and small change in y, that is delta u and delta y tends to 0. Now consider the incrementary ratio as delta y upon delta x is equal to delta y upon delta u into delta u upon delta x. Taking limit as delta x tends to 0 on both the sides. Limit delta x tends to 0, delta y divided by delta x is equal to, separating the limits here, limit delta x tends to 0, delta y upon delta u into limit delta x tends to 0, delta u divided by delta x. Therefore, using the statement here as delta x tends to 0, delta u tends to 0, right here, replace this delta x as delta u tends to 0. Therefore, the RHS becomes limit delta u tends to 0, delta y divided by delta u into limit delta x tends to 0, delta u divided by delta x. Consider this equation as equation number 1. Now, in the statement, given that y is differentiable function of u and u is differentiable function of x. Now, by using Leibniz notation, meaning of differentiable function of u and differentiable function of x is given as, if y is differentiable function of u means derivative of y with respect to u exists. Similarly, if u is differentiable function of x means derivative of u with respect to x exists. And according to Leibniz notation, this can be written as dy by du equal to limit delta u tends to 0, delta y divided by delta u, and du by dx is equal to limit delta x tends to 0, delta u divided by delta x. Consider combinedly this as equation number 2. From equation 1 and 2, using these limits, in equation 1 we get LHS as it is, limit delta x tends to 0, delta y divided by delta x is equal to dy by du into du by dx. Consider this as equation number 3. Since, observe the RHS of equation 3, it is represented in the form of derivatives dy by du into du by dx. So the limits are exist and can be written in the form of derivative. Since the RHS of equation 3 exists, LHS also exists. So LHS exists means this limit exists, and again by Leibniz notation, if this limit exists, it can be written as dy by dx. Therefore, limit delta x tends to 0, delta y divided by delta x is equal to dy by dx. Therefore, from equation 3 becomes dy by dx is equal to dy divided by du into du divided by dx. This rule is known as chain rule, and this is the one of the important theorem in board exam. This theorem carry 3 or 4 marks. Now let us see some remarks concerned with the chain rule. Consider here again a chain of functions. If y equal to f of u equal to g of v, v equal to h of x. Y is differentiable function of u is differentiable function of v, and v is differentiable function of x. So by using chain rule, dy by dx is equal to, consider here chain of functions dy by du into du by dv into dv by dx. This is the chain rule. Now we will continue with generalization, as if y is differentiable function of u1 is differentiable function of u2, and so on, ui is differentiable function of un. Then dy by dx equal to dy by du1 into du1 by du2 into du2 by du3, and so on, into dun divided by dx. हा रिमार्क ॲक्च्युली लक्षात राहत नसेल तर ज्यावेळेस आपण एक्झाम्पल ॲक्च्युली सॉल्व करणार आहोत त्यावेळेस हा रिमार्क तुमच्या लक्षात येईल. जेवढे नंबर ऑफ फंक्शन्स असतील, इनर फंक्शन्स असतील, तेवढे नंबर ऑफ टाइम्स आपण इथं डेरिव्हेटिव्हच्या टर्म्स मल्टिप्लाय करणार आहोत. थर्ड रिमार्क आहे महत्त्वाचा, इफ y equal to f of u is differentiable function of u and u equal to g of x is differentiable function of x, such that y equal to f of g of x be a composite function, then dy by dx equal to, firstly write derivative of this function, that means f dash of g of x, into derivative of this g of x is g dash of x. एक्झाम्पल सॉल्व करताना एक्सरसाइज 1.1 मध्ये आपल्याला याचा यूज करायचा आहे. dy by dx is equal to f dash of जे पहिलं फंक्शन असेल त्याचा डेरिव्हेटिव्ह लिहा एफ डॅश ऑफ जी ऑफ एक्स इंटू जे इनर फंक्शन असेल त्याचं डेरिव्हेटिव्ह इंटू जी डॅश ऑफ एक्स. नाव वी विल सी सम फॉर्म्युलेज derivatives of some standard composite functions. मागच्या वर्षी किंवा आत्ता रिव्हिजन पाहताना आपण डेरिव्हेटिव्ह ऑफ स्टँडर्ड फंक्शन पाहिलेलं आहे. त्याच्यावरून हे रूल्स क्रिएट केलेले आहेत, डिराईव्ह केलेले आहेत. तुमच्याकडे PDF बुक असेल तर त्याच्यामध्ये हा टोटल टेबल आहे. त्यापैकी आपण एक दोन बघूया आता. एफ ऑफ एक्स रेज टू एन हे कॉम्पोजिट फंक्शन आहे. रेज टू एन असेल तर इथे डेरिव्हेटिव्ह काय येणार आहे पहा. या फंक्शनचा डेरिव्हेटिव्ह पॉवर फंक्शन सारखं ट्रीट करायचं. तर एन इंटू एफ ऑफ एक्स रेज टू एन मायनस वन इंटू डेरिव्हेटिव्ह ऑफ दिस फंक्शन इज एफ डॅश ऑफ एक्स. रूट ऑफ एफ ऑफ एक्स डेरिव्हेटिव्ह ऑफ रूट एक्स is 1 upon 2 root x. Similarly, derivative of root of f of x is 1 upon 2 into root of f of x into f dash of x. Derivative of 1 upon f of x is minus 1 upon f of x square into f dash of x. Derivative of sin of f of x is cos of f of x into f dash of x. Similarly, we will derive all the formulas for derivatives of standard composite functions. You can see in the PDF book. Now we will start exercise 1.1. First example is differentiate with respect to x. F of x is equal to or y is equal to x cube minus 2x minus 1 raised to 5. Y equal to differentiate with respect to x. dy by dx is equal to, use here f of x raised to n. n is equal to 5. f of x equal to x cube minus 2x minus 1. 5 into total f of x raised to n minus 1, that is 5 into x cube minus 2x minus 1 raised to 5 minus 1 into derivative, that is f dash or d by dx of this f of x, d by dx of x cube minus 2x minus 1 equal to 5 into x cube minus 2x minus 1 raised to 4 into x square minus, derivative of x cube is 3x square and derivative of 2x is 2. Consider next example. Differentiate this root of x square plus 4x minus 7. Y equal to root of, consider derivative of root of f of x, 1 upon 2 root of f of x, therefore 1 upon 2 into root of x square plus 4x minus 7 into d by dx of total f of x, x square plus 4x minus 7 is equal to 1 upon 2 into root of x square plus 4x minus 7 into derivative of x square is 2x and derivative of 4x is 4. Derivative of 7 is 0. Therefore, the term will be 1 upon 2 into root of x square plus 4x minus 7 into 2x plus 4. Taking common 2 into bracket x plus 2 divided by 2 into root of x square plus 4x plus root of x square plus 4x minus 7. Cancelling this 2 is equal to x plus 2 divided by root of x square plus 4x minus 7. So these are the simple examples on chain rule. In the next lecture we will continue exercise 1.1.